we're going to be looking at how to add and subtract rational expressions. So earlier we talked about how to multiply and divide. Now we're going to be discussing adding and subtracting. So just like when we add with normal fractions, you do need to find what's called the least common denominator of two rational expressions when we add and subtract. So let's practice finding, since the least common denominator is actually just the least common multiple of the denominator. Let's practice finding the least common multiple. So let's start off with an easy one. Let's say I asked what the least common multiple was of 4 and 6. So some of you might know that off the top of your head, what the least common multiple is, which is fine. But there is a process if you're not too great at finding them just in your head. So what you're going to do is you're going to factor or expand both numbers as much as possible in terms of their prime factors. So 4 I'm going to write as 2 times 2. 6 I'll write as 2 times 3. And so what you're going to do is look at all of the different numbers that are involved. So I have 2's and I have 3's. You're going to pick out from the two numbers so of the 2's, which one has more 2's? This one does. So I'm going to circle the 2's in this one. Okay, of the two expansions, which one has more 3's? Well, this one doesn't have any 3's. This one has 1 3. So I'm going to circle that. Once I've done that, I multiply all the numbers I have together. So 2 times 2 times 2, times 3. 2 times 2 times 3. That's 4 times 3, that's 12. So that's my LCM, or least common multiple. So that's my answer. Let's try another one. Let's say 21 and 16. Okay, I'm going to write them both in terms of their expansions. So 23 is 3 times 7. 16, if I were to make a factor tree, would be 2 times 2 times 2 times 2. Okay, so I've got 2's, 3's, and 7's involved. So which of the two has more 2's? Well, this one definitely has more 2's. So you circle all of those 2's. Which one has more 3's? This one. Which one has more 7's? This one. So I circle them. If there was a tie, like let's say this one had a 7 as well, just 1 7, I would circle either one if there's a tie. Okay, so now I've got everything circled. I'm going to multiply everything together. So multiply 3 times 7 times 2 times 2 times 2 times 2. This is a pretty high LCM. You should get 336 equals your LCM. Okay. Next, let's do something a little different. So not only are we going to have numbers for this one, it's going to be two polynomials. So let's say I had a squared minus 6a plus 9 and a squared plus a minus 12. Okay, so I've got some multiplication addition and subtraction here. So to find the LCM when it's a polynomial, you need to get it into its factored form. So these are both trinomials that can be factored. So if I were to factor this, I need two numbers that add up to negative 6 and multiply to give me 9. Those two numbers are a minus 3 and a minus 3. Negative 3 and negative 3. Okay, if I factor the second one, I get a plus 4 times a minus 3. Because 4 times negative 3 is negative 12. 4 plus negative 3 is 1. Okay, so now when I'm looking for the least common multiple, I'm going to look at all the different factors I have. Okay, so my two factors are a minus 3 and a plus 4. So which one has more a minus 3's? This one has more a minus 3's, so I'm going to circle them. Which one has more a plus 4's? This one, so I'm going to circle them. Okay, so my least common multiple is going to be a minus 3 quantity squared, because a minus 3 times a minus 3, times a plus 4. That would be my LCM for that one. So you factor it, pick out which one has more factors of the two, and then circle them. Okay, next I'm going to have 3 different monomials here. So let's say I had 18r squared s to the 5th, 24r cubed, let's see, times s times t squared, and then 15s cubed t. And I wanted to find the least common multiple between those three. Okay, so I'm going to expand them since they're monomials. So 18, if I were to make a factor tree, I'm not going to do that right now, but I would get 2 times 3 times 3. R squared is r times s times s times s times s times s times s. Okay. Then I have 24. If I were to expand that, I get 2 times 2 times 2 times 3 times r times r times r times s times t times t. Again, if you don't know these expansions right off the bat, make a factor tree. 15 is 3 times 5. Then I've got s cubed times t. All right, so let's look at each of the prime factors. Which one? I've got 2s, 3s, and 5s for the numbers. So which has the most 2s? This one does. So I'm going to circle it. Which one has the highest number of 3s? This one has 2 3s, that one has 1, that one has 1. This has the most. And then of the 5s, this is the only one with a 5, so that one wins. Okay, and then r's, this one has 2 r's, 3 r's. This one wins. For the s's, top one wins. For the t's, this one has the most. So my LCM is going to be all of those things multiplied together. So it's going to be, if I multiply 3 times 3 times 2 times 2 times 2 times 5, I get 360. And then my variables are going to be r cubed, s to the 5th, t squared. That's my LCM. So I just multiplied all of my things that I circled together. Moving on. So that's how you find the least common multiple. Now let's talk about adding and subtracting fractions. So in order to add and subtract, like we mentioned earlier, they must have a common denominator. This isn't true for multiplying and dividing, but it is true for adding and subtracting. So let's go back to just fractions that you learned a while back in elementary school. Let's say I asked you to add 2/3 plus 3/5. Okay. 3 and 5 are my denominators. Those are not the same. They're not common. So I want to think of a common denominator. The least common multiple of 3 and 5 is 15. Okay? 15. So I need to ask myself, what did I multiply 3 by to get to 15? Well, I multiplied it by 5. So I need to do the same thing to the top. 2 times 5 gives me 10. How did I get from 5 to 15? I had to multiply by 3. So do the same thing to the top. 3 times 3 is 9. Now my denominators are the same, so I can add. My answer is going to be 10 plus 9. That's 19 over 15. 19/15 would be my answer. Okay, so a similar idea holds for when I'm adding and subtracting with monomial denominators, like this. Okay, so clearly my denominators are not the same. So since you might not know the least common denominator right off the bat, I'm going to go over here and do some side work and do this process to try to figure out the LCM or LCD. All right, so I've got 6b and 14a squared b squared. And I'm trying to find the least common denominator. So expand both of those. 6 would be 2 times 3 times b. 14 would be 2 times 7 times a times b times b. Now I'm going to do my circling. So which one has more 2's? Well, actually there's a tie. So circle either of them. It doesn't matter which one. Which one has more 3's? This one. Which one has more 7's? This one. Which one has more a's? This one. B's? This one. So least common multiple, you're going to multiply everything together. 2 times 3, 6 times 7 is 42. And then I have a squared, b squared. So that is my least common denominator. That's what I'm going to try to get. So I'm going to end up Just write this down for now. You'll see what I'm doing in a minute. Okay, so what I'm going to try to do is get my new denominator to be 42a squared b squared. Okay, since that's what I got for my LCM or LCB. So I need to think to myself, okay, what do I have to multiply 6b by to get to 42a squared b squared? Well, I know 6 times 7 is 42. So I need a 7. I don't have any a's originally, so I'm going to need both of those a's, a squared. And I only have one of the b's, so I need to multiply by a b as well. Now, whatever I do the top, I must do to the bottom. Or sorry, whenever I do the bottom, I must do the top also. So it's like I'm multiplying by this by a value of 1 if I multiply by something with the same numerator and denominator. So I'm going to multiply by 7a squared over 7a squared b over 7a squared b. So multiply the top out, and you get, so 5 times 7 is 35. You get a to the 4th b when I multiply straight across. Now I look at my second one. How did I get from 14 to 42? Well, 14 times 3 is 42. That must go here. And then let's look at my variables. A squared, b squared. A squared, b squared. Okay, I'm good with that. I don't need to multiply by any variables. So it's got to be the same on the top and the bottom. So it has to be 3 over 3 that I'm multiplying by, which is a form of 1. So since I multiplied by 3 on the bottom, let's do the same to the top. Okay, 9 times 3 is 27. So now I have common denominators, so I can add them, just like I did up here. Okay, I'm going to add, so my denominator is 42a squared b squared. And I'm going to add 35a to the 4th b plus 27. Now those are not like terms, so I can't combine them. So I'm just going to leave it as 35a to the 4th b plus 27. And that would be my final answer. Okay, let's try one more just like that. Actually, pause the video and try this one out.